Hello everyone, my name's Richard-Bollans and today I'm going to be presenting some work that I've been doing with Lucia Gomez-Alvarez and Tony Cohen, looking at the semantics of spatial prepositions, and in particular the polysemy that they appear to exhibit. Okay, so for some background, we're looking at modelling spatial language in situated dialogue, in particular for referring expressions. So these are noun phrases which serve to identify a particular object under some common ground. So what is polysemy? As opposed to homonymy, where senses are semantically distinct, we say that a term exhibits polysemy if it denotes multiple related senses, and we call these distinct senses polysemes. For example, a figure object may be on a ground object if it is resting on top of it, like a sort of canonical example of on, such as a book on a table, or if it's attached to the side of it, like a clock on a wall, or even simply in contact with it, so something like a balloon on the ceiling. The question is how the semantics of polysemous terms should be handled in grounded settings. Firstly, in this particular work we restrict ourselves to the spatial prepositions which appear to have an ideal meaning, which I'll discuss later, and also to exhibit polysemy at the kind of room scales we're considering. We consider these to be in, on, under, and over. So, to briefly introduce polysemy for spatial prepositions, here are some examples of the variability that the preposition on seems to express. These are some examples from some work by Bauman and Choi. We can see that there is quite a variance in the kinds of meanings that on can express. It's not always the canonical sense that you see in example A. Sometimes the figure is attached to the side of the object, like in C or D, or even under the ground object, as in example E with the apple on the twig. So looking at these examples, we may say there is some variability, but there's a common theme of something like support. But even sometimes this isn't the case, so on may be used to denote proximity, like there is a chest of drawers on the far wall. So before getting into the model and the account of polysemy that we've created, I'll briefly explain the data collection process and environments that we were using. So we conducted some experiments using virtual environments to create 3D scenes in which participants performed a couple of annotation tasks. Firstly, we used a preposition selection task that you can see in figure 2, where participants label configurations with prepositions. And secondly, we use a comparative task that you can see in figure 3, where participants are given a description and asked to select an object which best fits the description. So in earlier work we used this data to create a model based on Roche's prototype theory, which is trained on categorical data from the preposition selection task and provides a measure of typicality for configurations, which is tested on data from the comparative task. And the model performs better in this task when it agrees with participant judgments in general. So the question is, how can we improve this model by incorporating polysemy? So the first challenge is to identify the different polysemes that may be expressed by a preposition so that their semantics can be learnt. For each preposition, the goal is to construct a meaningful set of polysemes where, when given a configuration in a scene, there is a method for determining which polysemes the configuration could be an instance of. So we see here in figure 6 some instances of the preposition on that may be considered different polysemes. We could say that the book is on the board, or the clock is on the board. Also, in some ways the jar is on the board, and each of these instances appears to represent a distinct polyseme or sense. So why do we differentiate these senses, and what makes them distinct, and how can we identify the particular senses? So I'll first give some background on spatial prepositions, which also provides some of the motivation for the approach that we've taken. Herskovits argued that the meanings of spatial prepositions are centered around ideal meanings, and that the variety of usages which arise from transformations which are applied to the ideal meaning. So, for example, the preposition in represents an idea of inclusion or containment, which is sort of represented by the image schema that we see in figure 7. In terms of the transformations that arise, we can imagine that we could still say that A is in the circle if we move the position of A slightly. So if we move it upwards and it's still sort of overlapping the circle, we might still say that A is in the circle. There's also more sort of complicated transformations that can happen. There's abstractions which may be performed such that in still applies to A in the circle even when A is not geometrically in the circle. So I've kind of introduced the notion of ideal meanings there, and they appear to give us a sense that we should distinguish, and to begin with we attempt to characterize the ideal meanings of each preposition. So we take inspiration from the literature and sort of our intuition to create representations of these canonical senses. We also suppose that these terms have both geometric and functional components, as opposed to a purely geometric ideal meaning. In previous work we've looked at how these functional notions of support and location control can be derived from scenes. So, as an example, the canonical sense of the preposition on we represent by a high degree of the functional notion support, as well as contact and this above feature. In this way, each preposition is associated with a set of conditions which represent its ideal meaning. So we've kind of covered there maybe the ideal sense of each preposition, but then there's the sort of variety of non-ideal senses. So what are these non-ideal senses, and how do we distinguish them? Herskovits argued that the polysemes senses, these non-ideal senses, arise from some sort of transformations from the ideal meaning. This relates to the principled polysemy approach of Tyler and Evans, which relies on a similar notion to an ideal meaning and aims to provide criteria for when senses are genuinely distinct. To simplify this principled polysemy approach somewhat, we use this criterion here, which says that we say a sense may be considered distinct if the sense meaningfully differs from other senses with regards to some spatial or functional features. So here, meaningfully differs is doing a lot of work, and more concretely we take a meaningful difference to be whether a sense satisfies or violates one of the conditions of the ideal meaning. So the distinct senses we have are then the ideal meaning and the various non-ideal meanings that can be generated from violating combinations of the ideal conditions. Following with this example of on, if we look again at figure 8 here, we can see how the criterion works. So the configuration of the book on the board is similar to the ideal meaning. It's sort of precariously on top of the board, but let's say it's the canonical usage of the preposition on. There's a high degree of support, contact, and it's above the board. The clock and board has a high degree of contact and support, but the clock isn't above the board. The jar is on the board in a poor sense of on, with only minimal contact. If there was so these appeared to be three different senses which the criterion distinguishes. If there was, for example, another object hanging on the board, the feature values of that configuration may be different from the clock and the board, but it would still be the same sense as the clock and the board, as there's no distinct shift in the meaning. So we now have a set of polysemes for each preposition based around an ideal meaning, and we can train our model to assign a typicality score to a given configuration with respect to a particular polyseme. So if we look at figure 9 here, the configuration A in the table, let's say that's the canonical sense of on, and we can assign it a score of, say, 0.7 for how well it fits the canonical sense. So how then do we exploit this knowledge in processing referring expressions? Consider the configurations again in figure 9. So we have an example of two objects on a table in different senses. As we're saying, A is the canonical sense of on, call this sense P1, but not a very good example of the sense. Let's say it gets a score of 0.7. B represents a sort of weak sense of on. We'll call this sense P2, but it's a good example of the sense, so say it's assigned a score of 0.8. If we simply use these measures to interpret the statement the object on the table, we would pick object B, which would generally be incorrect, as it seems there's some sort of hierarchy of senses. The canonical sense is a better sense than this other weaker sense. So to manage this apparent hierarchy of senses, we assign a rank to each sense, which reflects how likely the preposition is to be used for the sense. The typicality, which the model then assigns to a configuration with respect to a given polyseme, is then adjusted based on this rank. The overall typicality for a configuration is then the largest typicality value with respect to any potential polyseme when modified by the rank, as in the equation given here. So this set of polysemes is the potential polysemes. Okay, so finally we test how well typicality scores are assigned by the model when the model is trained on categorical data and tested on descriptions in the comparative task. The models perform better the more they agree with participant judgments in this comparative task, as I said earlier. The Polysemy model I've described is a copy of this baseline model, which is from previous work, except the Polysemy model incorporates polysemy. We also constructed a k-means model, which is discussed in the paper and is based on a k-means clustering algorithm. We can see that the Polysemy model in general performs better than the baseline and k-means model, in fact significantly so over the baseline, and it appears that this approach to capturing polysemy is useful. Okay, so to summarize, we've provided a method of distinguishing meaningful clusters within categorical data on spatial prepositions, which is based on ideal meanings and the principal polysemy approach. We've also introduced the notion of polyseme hierarchy to aid typicality judgments and created a measure of this from the data. Thank you all for your time. I'm looking forward to any questions and comments.